All right, in the second video, I'm going to go over how to construct two sample T confidence interval to compare population means. Now, this is going to be a fun one because all we get to do in the hypothesis test is whether, we test, are they equal? If we reject the null, I guess we can say they're different, but what kind of difference are we talking about? So actually the confidence interval is, I think, much better because we get to estimate what is their difference, right? So this is going to be a good one. All right, hold on. Where am I? And unfortunately, Larson textbook didn't cover um, this topic. There was a tiny little section that said extended topic, but I had to borrow a couple examples from my previous textbook, the Agresti book. But I was able to pull homework problems from our textbook, this semester Larson book. So you should still be able to click on help me solve this if you want to use the formula. But I will just continue using StatCrunch to do this confidence interval, okay? So click on it. Let's see. Looking at their difference, okay? So let mu1 be the mean of population 1 and let mu2 be the mean of population 2. Their difference. Are they the same or are they different? How do you find that out? You're going to subtract them, you guys. So if you subtract them, mu1 minus mu2, okay, that's what we're trying to estimate, okay? Listen, if they are the same, there's no difference, right? If they're the same, you subtract them, you're going to get 0. Makes sense, right? And with a simple algebraic manipulation, you can add mu2 to both sides. You go right back to mu1 equals mu2, right? So if the two populations are the same, there's no difference between their averages, then if you subtract them, you will get 0. Makes perfect sense, right? But what if they're different? What if they're different? Let me go over this. So if you subtract two population averages and you get a 0, that means there's no difference. If you construct a confidence interval, I want you to look at that confidence interval to see if your interval contains 0. If the interval contains 0, then we're going to say they are not different. Okay, there's no difference. Okay, they're the same. So whenever you're constructing these confidence intervals to estimate differences, you want to see if 0 is in your interval. So the lower bound will be in the negatives. The upper bounds are in the positives. Okay, if that happens, then we'll get to say there's no difference. If there is a difference though, if you do mu1 minus mu2, you're not going to get 0, right? If they are different, you subtract two different things, you don't get a 0. Two different cases, okay? Well, but one thing for sure, because their difference is not equal to 0, the confidence interval does not contain 0. So either it is completely positive, both the lower bound and the upper bound is completely positive, or they are completely negative. Both the lower bound and the upper bound is completely negative, okay? So let's go and talk about that more. Remember subtracting, okay? Like in elementary school, your teacher only tells you you can only subtract big number minus small number. But then like in middle school, your teacher says you can subtract small minus big and get a negative number, right? So it's that idea. If the number that you are subtracting from is bigger, like mu1 is bigger, mu1 minus mu2, a big minus small will give you a positive number, right? So if your confidence interval is completely positive, okay, both lower bound and the upper bound are positive numbers, then what we know is that mu1 is bigger. What we subtracted from is bigger. Makes sense, right? But what if it's the opposite? When you do mu1 minus mu2 and it came out to be completely negative, okay? That means mu1 was smaller. When you do small number minus a big number, like if you do 3 minus 10, 3 minus 10 is not positive 7. 3 minus 10 is negative 7, right? So if you do a small minus big, that's when you get a negative. So when the confidence interval is completely negative, okay, it does not contain 0, then what we get to say is mu1 must be smaller than mu2. Or in other words, mu2 is bigger than mu1. So that's how you can look at whether the confidence interval is completely positive or completely negative to estimate which population has a bigger average. So I'm going back to Canvas because question number 2 is asking, what is the number we are looking for when constructing a confidence interval to estimate the difference between two populations? Listen, the number is 0. Why? Because if there's no difference, if they are truly the same, really, they're same enough, then it's going to contain 0. Okay, it's going to contain 0. Lower limit will be negative, upper limit will be positive. Okay, but if they are the same, it's going to have a 0 in it. Okay, question number 3, I'm asking you this. A confidence interval to estimate mu1 minus mu2 came out completely positive. What does that mean? When you do a subtraction and the answer comes out to be positive, that means the number you subtracted from was bigger. So guess what we know? Mu1 must be bigger. So you click on mu1 is bigger than mu2. Question number 4, I'm asking you, the confidence interval to estimate mu1 minus mu2 came out to be completely negative. Well, what does that mean? When you do subtraction and the answer comes out to be negative, that means you did small number minus big number. So mu1 must be smaller than mu2. So you click on that. So we just went over this attendance quiz together. So hopefully you are watching. All right, question number 5. Hey, it's easy. Let's take care of this. Which cannot be a null hypothesis? Now remember, to be a null hypothesis, you must have an equal sign, right? Either equal sign or greater than or equal to or less than or equal to. So take a look at those two that I clicked on. This one cannot be a null hypothesis because it says less than. It doesn't say less than or equal to. So this only can be a alternative hypothesis. This one also only has greater than symbol. It doesn't have greater than or equal to symbol. This can only be an alternative hypothesis, but not null. But everything else, as you can see, all have equal to symbol, right? So the other guys can be null hypothesis, but these two cannot be null hypothesis, okay? All right, that's it for this attendance quiz. So hopefully you guys submit this and get 5 out of 5. Okay, I'm going to close this, but I will go back to the slide and talk about creating a confidence interval. I see some of you are in here studying for it. Okay, come back over here. Present. Okay, constructing and interpreting confidence interval to compare two population means example number 1, and I have data for you. Oh goodness, we're gonna have to do some typing ourselves. Okay, a teaching assistant collected data from students in 1 over classes to investigate whether study time per week, average number of hours. Now this is per week, this is not per day. So nobody's studying 35 hours a day. This is per week. I think, what? This one student's only studying 2 hours per week. What? All right. But what they are doing is they are trying to see if there's a difference between students who plan, whoopsie, what was that about? Between students who plan to go to graduate school and those who did not. So this is what I'm thinking, you guys. Grad school, like med school maybe, medical school or law school. I'm thinking if one is trying to go to these graduate school, wouldn't they study more? I don't know. That's what I'm thinking. They like studying. That's why they want to go and continue working on their degree in a grad school. But, well, we'll see. Are they different? And as you can see, these are two different groups. They're independent groups. And just by the look of the length of these numbers, there are more students who are trying to go to grad school, and there are less students who are not. They're done with grad school. They're done with school. They're not going to graduate school. So what we're going to do is we're going to go and enter these data. And I think I took a screenshot of that over here, but let's do this together, okay? So in your StatCrunch, where is it? Ah, there it is. In StatCrunch, I'm going to go ahead and type in graduate school, and I will do no graduate school. I like to name my variables so that I know what I'm looking at. Okay, now numbers. How about I pause the recording and I type it, because it's going to take me 15 minutes to type this. I was typing it, and then maybe I could show you that I'm actually typing it. So sometimes you see something like this, you type it yourself too. I'm slowly typing these numbers. Hopefully I did not make a mistake. Okay, all good, all good. And then what we're going to do is we're going to do a t-test, all right? Go to stat, t-stat, to sample. What are we going to click on? With data, we have data entered in here this time. So they're going to, the StatCrunch is going to find the sample mean of each, sample standard deviation of each, sample size. They can just look at how many numbers we have for each column, but they're going to figure that out themselves. So I'm going to click on with data and then tell them the sample 1 is saved in graduate school. Sample 2 is saved in a no graduate school. Now we have to be careful. Do we pull variance? Okay, let's see. Did they say there is a reason for us to believe that population standard deviations are equal? I don't think so. So I'm not, the default is off. So I'm not going to click on pull variance. Unless they say it specifically, I'm not going to assume it. I actually think it's going to be different. I think it's going to be different. But, all right, how about the hypothesis? Mu1 minus mu2 is always going to be equal to 1. That's what we are assuming. We're going to assume they are not different. They study about the same amount. That's what we are assuming. And they really did not say which group is going to study more. I was just thinking, but if you read the word problem carefully, they're not really suggesting any direction. They're not saying students who are planning on going to graduate school tend to study more or tends to study less. They didn't really say anything like that. That's why I'm going to keep it as a two-sided test, which is not equal to. I'm done. I'm going to take a screenshot of this. Hold on, maybe the picture already is up here. Oh yeah, it's already up here. Yep. And then I'm going to go ahead and click on compute. The p-value came out to be 0.5726. Let's see if that is matching what I have over here. Oh crap. I forgot what we were doing. We were trying to construct a confidence interval. Look at me sitting here doing a hypothesis test. Gotta go back. Okay, I'm back here. I'm gonna do a confidence interval. Sorry, I was doing hypothesis testing instead of confidence interval. Okay, what percent did they want? Did they want 95% or 99%? They didn't really say it. They didn't really say it. So I guess we can always go with 95%. That's the most common one. I can do 95%. And I think I did that semester too, when I took a screenshot of this. 95%. It's a common one. Compute. And this is the table. And I will go ahead and copy this table. Sometimes the problems are so long, we're doing this and we forget what we were doing. All right, so let's see. My new picture and my old picture, they have different number. What must be the problem here? I think I have a typo. Wouldn't you think so? I think I typed something incorrectly because these two tables have different numbers. And the only thing that I don't believe is my typing skill. I probably made a typo when I was typing it. So I'm going to pause this recording for 1 second and I'm going to double check my numbers real quick, okay? I expected, I made a typo. Look at that. The last number is 5. My silly self put 15, so I'm going to fix that. And then I will go ahead and try this one more time and get this new table. But you do not have to worry about making a typo like I did, because all the problems on your homework, there will be a button you can click on to just, there will be a button that will send the data set automatically to StatCrunch. But I had to enter it myself, and my silly self had a typo. That's why the first table didn't match the answer. So here I have the answer, the confidence interval. So when you are looking at the confidence interval, you need to just look at the lower limit and the upper limit. So let me go ahead and draw a box around it. Okay, give me 1 second. I want the transparent inside. I want little thick bars. I want them to be red so that it stands out. And maybe I'll make it like dotted. Ta-da! So I want you to focus on that. So the confidence interval is from negative 2.143 to 6.6. Just to match the rounding type, how about I just round it like this? And what we need to think about, or what we need to talk about, is what significant number this interval contains. All right, take a look. The number is started from the lower limit is negative, right? And upper limit is positive, which means, can I go ahead and type it? 0 is included in the confidence interval. Oh my goodness, what does that mean? Which means at 95% confidence level, mu1, can I type in mu1? Mu sub 1 and mu sub 2, the sub 2 are not different. Okay, so what does that mean? I thought they were going to have different study pattern. People who plan on going to graduate school and people who don't plan on going to graduate school. But our confidence interval says with 95% confidence, we know the true population difference is going to be in between negative 2.1 hours to 6.6 hours. Because this interval includes 0, this means there is really not a big difference. Okay, they're probably about the same. That's what they are saying here. Okay, I'm gonna go and see if there's more explanation or interpretation. I think it's the same thing. So let's read this. Even though we just said it, let's read this. The 95% confidence interval for mu1 minus mu2, the average time for students who are planning to go to graduate school minus the average study time for students who don't plan on going to graduate school is from negative 2.1 to 6.6. What does that mean? We are 95% confident that the difference in the mean study time per week between the two groups is between negative 2.1 and 6.6 hours. We cannot conclude that the population mean study time differ for the two groups. If I please may add the reason, okay? Let's go ahead and add why. Because this confidence, whoopsie, I spelled it wrong. Because this confidence interval includes what number? 0. I need you to remember this for me, okay? Because 0 implies no difference. We cannot conclude that the population mean study time differ for the two groups because the confidence interval included 0 in it. Okay? And that's it. That's it for this example. Let's go over one more example and we are done with this lesson. Or maybe two more. And there's an extra example too. I think that one was pretty fun. All right, let's go over example number 2, which this time is with summary. A study of bulimia, like you eat food and then you go to the bathroom, you stick your hand in your mouth and you throw out the food, right? Among college women. So these college students, who are purposely throwing up after eating food. Women studied in the connection between childhood sexual abuse, oh goodness, and the measure of family cohesion. The higher the score, the greater the cohesion. Okay, let me keep reading. The sample mean of the family cohesion scale was 1.9. The sample average for family cohesion. So the higher score means what? They have a great cohesion with their family members. 1.9 for 11 sexually abused students. Okay? And their sample standard deviation was 1.7. It's given to us as like S equals 1.7. And 5.1 for 19 non-abused students. Okay, the sample standard deviation for non-abused student was 3.3. Before we go on, I just want to talk about these numbers, right? Can you see how the family cohesion score was much higher, 5.1 compared to 1.9? It was much higher for the non-abused students, right? Sexually abused students had lower score on the family cohesion scale, right? And talking about the difference in sample size, they were able to include 11 sexually abused students in this study, while they had a little bigger number, 19 non-abused students. Okay, so the sample size is different, but obviously, as you can see, we're working with independent samples. Nowhere in this problem they were, oh well, this is not for hypothesis test. I was going to talk about pool variance, but we're just probably doing the confidence interval here. Okay, so all the numbers are given. Two sample, we're comparing them. I can see non-abused students have higher sample mean, but is that difference statistically significant? What's their difference like? So let's go ahead and get started. Go to T-stat, two sample with summary, and let's go ahead and enter these data ourselves, okay? This was the problem. So I'll delete all these, I'll need them. Stat, T-stat, two sample, and they gave us the summary of what they found out. I'll just go in order. 1.9 for the abused students. Standard deviation is 1.7, and the sample size was only 11. Hey, that small sample size, wonder if the population is normally distributed. Let's assume it, okay? Let's assume it. This is too small, but I'm going to assume that the populations are both normally distributed. 5.1, 3.3, and the sample size is 19. I'm going to do a confidence interval, 95%. It's the common one. You can do 99%, but I'm going to go ahead and compute it. Okay, so look at the, oh, it's sad. Look at this. The lower limit and the upper limit. What can you say? The lower limit is negative. The upper limit is also negative. It is completely negative. Remember, when you do your subtraction, how do you get a negative answer? When you do your subtraction, how do you get a negative answer? Mu1 minus mu2 will come out to be negative if what you subtracted from is smaller. So we just prove that sexually abused students have lower average on this family cohesion, what is this, score. So they have lower cohesion with their family. This is a messed up example. But I took a screenshot of what we did, and here is the table. Why does it look different? Or was it different? Let me see. Oh, they're the same. Sorry, they're the same. The lower limit is negative 5.07 and upper limit is negative 1.326. It's the same thing. So this is okay. All right, so let's do an interpretation. But how about, before I do that, I'm going to go ahead and add my own words here. Notice the entire confidence interval is completely negative. It is not including 0. The fact that it is not including 0 just tells us the population average are different. They're different groups, okay? The second part, the second important thing is it came out completely negative. Because it came out completely negative, what we can say is that mu sub 1 is lower, or I should say less than mu sub 2. Where is it? welcome. Oh, where did that go? I am so going to buy an Apple mouse pad because Apple mouse, or like what's it called, magic pad, because Apple mouse is so sensitive, it just takes me to another slide when I'm not even done with my first slide, and that's been frustrating me the whole semester. Okay, let's read this. Notice that the entire confidence interval, which is from negative 5.07 to negative 1.33, rounded up, is completely negative, right? Both the lower bound and the upper bound is negative. It is not including 0. It doesn't include 0. Which means mu1 is less than mu2 because their difference came out to be negative. I think I can delete the last part. There it is. There it is. Okay, because mu1 stood for the average cohesion score from the abused group. What we just noticed is that there is a well, we'll go and read this. We're almost done. Okay, so the 95% confidence interval for mu1 minus mu2 is these numbers, both negative. The values in the 95% confidence intervals are less than 0. Both of them are smaller than 0. They're both negative, which implies that the population mean for sexually abused students is less than the population mean for non-abused student on this family cohesion score or the survey. Okay. All right. I'm actually done, so if you want to keep on watching, I just want to go over a couple more, just one more extra example, interpreting confidence interval that's already created. So looking at a confidence interval, what kind of decisions can we make? So here's a scenario. I was told that we need to go back to work starting in August. Sue had two choices of routes to get to her work. Or is it route or route? I just have two ways to get to work. I live in Fredericksburg, you guys, and I commute to Woodbridge. So if you are in Stafford County, you know the two options are I-95 or Route 1. Okay, is it route or route? Route or route?
Route.
Oh, crap. Route. Pandemic got my English all messed up. Okay, route. Okay, so either I take Route 1 or I-95. And you have to think about it. I'm like, which one is going to take me shorter time? Because I don't want to be stuck in traffic for so long. Oh, and I know they're building, my husband, he's a civil engineer. He's building an what's it called? Express lane. So when they open that up, maybe I should try that out. But is it really worth it, right? So let's see. Sue has two choices of routes to get to work. She wanted to choose the route that would get her to work fastest on average. To determine which route would get her to work faster on average, she randomly selected 10 days and took Route 1. It's like if you're not from this area, this is like Route 7 or like I-9, I-66 or 267, one of the roads on those 10 days. So I'm gonna drive on Route 1, Thomas Jefferson Highway. I think that's the name of it. Then she randomly selected different 10 days, and on those days I took I-95. Okay, I-95 on those 10 days. Okay, they're both horrible. Oh my God, especially on Fridays. They are so bad. But okay, say that she recorded the time in minutes it took her to get from her house to work on each of those 20 days. So both random, some days are Friday, some days are Monday, but because they're random, it's going to take care of that type of differences, right? From her data, she did the whole thing. Look, from her data, she constructed the 95% confidence interval for the difference in mean commuting time. And she did this. She did Route 1 minus I-95 commute time. Okay? And look, the confidence interval came out to be 3 minutes to 6 minutes. Based on this confidence interval, is there evidence to indicate the average commute time is different for Route 1 than I-95? What do you think? Yes or no? What do you think? Absolutely, right? Why? Look at the interval. From 3 minutes to 6 minutes. They are both positive. It does not include 0. So there is a difference. Who is taking longer? Which road is taking longer time? See, to get a positive answer from subtraction, you need to do big number minus small number. Makes sense, right? So what I just got is on average, Route 1 takes about 3 to 6 minutes longer than I-95. So here's the conclusion. There is evidence at the 5% significance level. And if you're like, didn't you just say that we are doing a confidence interval? Why are you saying significance level, right? But hold on. This was a two-sided test because I didn't really know which route was going to take shorter time. If you do 95% plus 5%, you see how it's going to be equal to 100%. So 95% confidence interval has 2.5% to the left and 2.5% to the right. So this is the same as doing a hypothesis test at alpha level 0.05, okay? There is evidence at the 5% significant level to indicate that Route 1 has longer average commute time, because when I did Route 1 time minus I-95 time, I got positive numbers. So which one should I take? Would you take the road that takes you longer to get to your work? Or would you take the road that will take you shorter? I'm going to take I-95 if this is true. So I-95 gets Sue to work faster. If I want to get to work fast, okay? Shorter average commute time on average, since the entire interval is completely positive and 0 does not fall between the bounds of the confidence interval. Even though if somebody's just reading the slide, I think it's still easier than reading it. But hopefully I'm adding enough to my presentation so that I'm adding a little more value to my recordings, okay? But because this interval was completely positive, what I know is that Route 1 is going to take longer time compared to I-95. So I'm going to take I-95, okay? I-95 it is. Oh, something else here now. Suppose that this time, Sue's not going to stop. Sue constructed the 95% confidence interval for the difference in mean commuting time. This time, the toll road. Do they have a name for toll road in I-95? Okay, but toll road minus I-95. I'm thinking the answer is going to come out to be negative. Why? Because shouldn't toll road take much shorter time? Because I heard like one of my colleagues who works in Annandale campus, she's taking, if she takes toll road, she says she pays like $10. That's a lot. If I'm paying $10, I should get there much quicker than the free road. So if I do toll road minus I-95 and do a confidence interval, whoopsie, what was that? The confidence interval comes out to be from -5 minutes. I like how this lower bound is negative and upper bound is, it's 1. I hate it. The upper bound is positive. What does that mean? You know what I wanted? I wanted this confidence interval to be completely negative. Both negative lower bound and the negative upper bound. Why? Because that means we're doing small thing minus the big thing, or short commute time minus the long commute time. I wanted to believe what I'm paying for at the toll road is worth it. Well, guess what this includes? In between -5 and 1, in between a negative number and a positive number, there is 0. Based on this confidence interval, is there evidence to indicate average commute time is different? No. There's not enough evidence that 5%. Why? Because the 0 is in this confidence interval. So when any time your lower bound stretches to negative number and upper bound is positive, that means they're probably the same. They're about the same. Well, if I'm like really late and still will take the chance, on average, there's really not a big difference. That's what we found out. But if I try to find the margin of error, we can go ahead and just subtract, get the how long this interval is. From -5 to 1, there is 6, right? 6 minus divided by 2. So the margin of error is 3, okay? 3 minutes. And the point estimate, at least, point estimate is, if I can add them together and divide by 2, what's in the middle of -5 and 1? It's -2. So the point estimate alone is telling me that toll road is going to take me to work 2 minutes faster than I-95. But if I create a 95% confidence interval with a margin of 3 minutes, margin of error of 3 minutes, okay, it's not really that different. So after looking at this, I don't think I will take the toll road unless I'm running really, really late for my class, right? Then I will just go ahead and take the toll road. But because it had included the 0 in this confidence interval, we're going to say, hey, there's not a significant difference. There's not enough evidence to say that there is a difference, okay? Guys, that's it. That's it. It's been a 35-minute video, probably not short video, but I went over all the slides on our first part 1 of 2 sample statistical inference. I hope this was helpful. This is, I think, the first full-on lesson video that I recorded. So I will come back and record data assignment 5 and have those available for you too soon. Okay?